It's rare that the first idea that an engineer comes up with is the best one. Design is normally a process of iteration, where engineers come up with an idea for a design, implement it, and then test it. The results of those tests then need to be evaluated before a new design change can be made. Now, in this process of iteration, the step of running the tests and evaluating the results can be time-consuming and is prone to error. Engineers may misread or misinterpret results. In order to enable engineers to iterate more quickly, therefore shortening the development cycle and producing better designs, we need to give them ways of automating the test process and the evaluation of the results. To show you how this can be done, we're going to use the Simulink report generator to run a set of tests and to automatically document and evaluate the results. We'll see that the document that is produced will have screenshots of the model, of plots, and indicate whether or not the design has passed or failed certain tests. And these documents can be used to document the performance of a design. I'll now show you an example of one of these reports. So here is an example of a report produced by the Simulink report generator. It's an HTML document that's broken up into different sections. For example, an ideal pitch test, a hydraulic pitch test, and so on. If I scroll down the document, we can see that we have included MATLAB code, a screenshot of the model, screenshots of the different plots that were produced that show how this design performed, and even a set of text that says that this design has acceptable performance for this test. Now, to show you how we can automatically produce this result, I'm going to open the Simulink report generator. Here you can see a template where we have set up a report to be run. We're going to run two different tests. One for a wind test where the wind starts from no wind, accelerates, and then comes back to no wind. And then another test where a high-speed wind test where the wind is too fast for the wind turbine. If I click on this button, it will start running the report. We'll see that the template that we have set up configures the turbine for the first test and starts it running. And we can see on the plots over on the right-hand side that the simulation is running, and it is currently running the test with the wind vector that we tested before. Again, no wind, accelerate to a certain speed, and then the wind dies off. During the simulation, we can see the results. At the end of the simulation, the Simulink report generator will take screenshots of different portions of the model and of the plots, and then automatically put that into the report. At the conclusion of this test, the Simulink report generator will configure the model for the next test. So we're almost at the conclusion of this model as the rotor is spinning down to a stop. Screenshots are now being taken, and now we can see that the model has been configured for the next test, where we are using a different set of test data for the wind. We can see that the performance is different, so we do know that we're using a different set of test data. And then at the conclusion of this test, the same process will be performed. The Simulink report generator will take screenshots of the model, of the different plots, and then put them automatically into an HTML file. We can use MATLAB code to evaluate the results. We can use other methods in order to determine what actually goes into the report. So now the tests are complete. We can see that an HTML document has been produced, and if we go to the different sections, we can see screenshots again of the model, the plots, and a table of data at the end. There are a number of different things you can do with the Simulink report generator, but again, the goal here is to speed up iteration. We've automated the running of these tests and the documenting of the results.